Good morning, everyone. Today we're going to be starting our review of Chapter 10. This is Converting Units of Measurement. If you are looking at this, if you follow the arrow, you should all be very familiar with this chart. This is your formula sheet that you would normally get on your PSSAs. The reason we're looking back at it is because it directly relates to our standard below and our objective for today. So we are going to be converting between different size measurement units within a given measurement system. The table of equivalencies, what you see right here, this will always be provided to you if you are doing problems where you are converting between units of measurement. Keep in mind, when you're older, you know how much I love to cook and bake, I still have to look up things like how many pints are in a cup or how many cups make up ounces, thinking about pounds and ounces as well. Keep in mind, in the United States, we use standard conversions or the customary system of measurement. Everywhere else in the world, they use the metric system of measurement. So what that means for us often is that we have to learn both. Mostly because if you're going to be baking, if you're going to be playing sports, if you're going to be working on any type of engineering or automatics, you're going to need our standard system if you're operating within the United States. But if you're going into science, if you're going into medicine, the medical field in the future, you're going to need our metric system also. So there will be times where you use both systems. Moving on. We're starting our day today with a number sense routine. That is which one doesn't belong. Remember, the most important thing for which one doesn't belong is to tell me your why. So feel free to pause the video here, take out your notebook, do it on a loose leaf piece of paper, or in Google Classroom. So I've been starting to post these every day in Google Classroom. So feel free to go to Google Classroom and let me know what you're thinking there. I thought today's was appropriate, being that all four of them are tools. So, thank you to Ms. Denahu for making these which one doesn't belongs. Remember, the most important thing is for you to tell me why you think what you think. So we would be starting today's lesson with the turn and talk. So what are some things people measure? So I want you to take a minute, just think to yourself, maybe your siblings are around and you just want to talk to them. What are some things that we measure? And then what are they measured in? So types of units. What do we measure why do we measure things? What things do we measure? And how do we measure them? Feel free to pause the video so you have time to think this through, as much time as you need, and write some thoughts down. Normally I'd be circulating the room, I'd be listening in, I'd call on a couple people to share their thinking. So we don't get to do that via video, but I'm really looking forward to hearing all of your brainstorming and everything you've come up with. That brings me to today we're starting the metric system. The three things, a lot of the things you came up with probably that you measure can either be measured by length, capacity, and weight. So if I'm talking about length, the length is the distance measured between 2 points. So you may have come up with things like feet or miles or yards, inches, right? That is what we think about length in the customary or standard system. We'll come to that on Monday. In the metric system, what they use is meter. I would ask you at this point, where have you heard that before? What unit are you familiar with that includes meters? And someone would definitely tell me centimeters, Ms. Seraphin. Centimeters are often on our rulers. So let's think about meter and centimeter and keep those in our brains. Capacity. The capacity of a container is the amount that a container can hold. So if I have a measuring cup, you think about cups, obviously. We're very used to cups and pints and gallons and quarts in the United States. We'll get back to that again on Monday. What you may be familiar with as well, maybe you're going out to buy soda at the store. They come in liter and half-liter bottles. So liters is how they use the metric system to measure capacity, or how much a container can hold. Finally, weight. The weight of an object, and I know it's cut off a little bit by my board here, is how heavy the object is because of its mass and gravity. Remember, mass is how much something is made up of. Gravity is that force that all of you are very familiar with that's pulling us towards what has the most mass. So our weight is calculated because of those two things, and it's pretty much just how heavy something is. We're very used to measuring ourselves in pounds, but in the metric system, they measure things in grams. You may have heard, and at this point I would ask for some volunteers, what do you know about that unit? What sounds familiar to you? And someone would have told me, but Miss Seraphin, kilograms. So I want you to think about those things that you're telling me. Centimeters, kilograms. So today we're going to dive into what these units are and a little bit more about how we can get to things like centimeters and kilograms. So I want to start by showing you this bar at the top. Each of these in the middle, this bright yellow box, those are our base units. So length, meter, capacity, liter, and then weight is our gram. Then I would ask, what do you notice about these boxes on the sides? Eventually you would tell me these, Miss Seraphin, are prefixes because they go in front of the word, right? So we would have decameters, decaliters, and decagrams. Then we would have hectometers, hectoliters, and hectograms. Finally, kilometers or kilometers, kiloliters, kiloliters, or kilograms, kilograms. Some of those sounded familiar. I know deca and hecto might not have been. If I go the opposite way, I have decimeters, deciliters, and decigrams. I want you to think to yourself, how are deca and deci somewhat similar? Then, sounding familiar again to us, we've got centimeters, centiliters, and centigrams, right? Centigrams. Centimeters. Then, milli would be the last prefix we're going to talk about today. Millimeters, I know, is something that's often familiar. Milliliters and milligrams. So, what do these prefixes mean? I know you guys didn't think today was going to be a vocabulary lesson. So, let's break that down. Deci and deca. Hecto, kilo, and you've got all of these power of tens underneath. Centi, milli. Someone would tell me, well, Miss Seraphin, I think milli sounds like a million, right? And centi, I don't know. What else do you know that has centi in it? Milli is not a million, by the way. We'll come back to it. Centi, I would ask, well, what do you guys know about a century? And someone would say, oh, well, that's 100 years. So I'm going to say centi has something to do with 100. So if you have that as your starting point, what do you know about deci then? If we're thinking about powers of 10, someone's going to tell me, well, deci has to mean 10. And if that's right, milli has to mean, let's guess it, we're going to go with 1,000. And then I ask you, well, what about this side then? Deca looks a lot like 10. Hecto, that even kind of sounds like 100. Kilo, I think we're talking about 1,000 there as well. So the difference, deca is 10 times more. So there are 10 decameters. It's larger. 10 meters make up a decameter. Hecto, it's 100. There are 100 meters in 1 hectometer. And that means kilometers, there are 1,000 meters in 1 kilometer. And that means if these are all getting bigger, these are larger units, a kilometer is going to be a lot larger than a meter. Then what does that mean about our deci, centi, and millimeters? Well, I'll ask you, when you look at a ruler and you see a centimeter, it's usually really, really small. So over here we're getting smaller. So this doesn't necessarily mean that it's 10 times more. This is actually 1/10. So that means that there are 10 decimeters in 1 meter. I'd ask you now, how many centimeters are in 1 meter? You would tell me there are 100 centimeters making up 1 meter. And then if I asked you how many millimeters make up 1 meter, you also would tell me, I think, Miss Serapin, that there are 1,000 millimeters making up 1 meter. What you'll notice is these units, in order to show you these prefixes, the units change so that it looks like km. Km, you look back up at all of your prefixes. K stands for kilo. Over here, you've got hectometers, because you have your H. DAM, you're looking at decameters. That's how they changed deca to deci. The DA stands for deca. Kilometers to meters. Centimeters to millimeters. Milliliters to deciliters. So let's talk about how you do this. It's all about scooping, if you remember. So, before we jump into how we do that, before we jump into the problems, I just want to point out this vocabulary link at the top. It is just a funny song to help you remember the order of the prefixes. After you remember the order of the prefixes, it's as simple as remembering our scoop problems. So, because something is either 10 times more or 1/10 of, right? 10 times less, we can use that to help us out. So if I have 115 kilometers, if I'm going to, think about that, 115 kilometers. Kilometers is 10 times larger than hectometers, which is what we're trying to get to. So if kilometers is 10 times larger, that just means I have to multiply by 10 to get hectometers. If I'm multiplying by 10 here, that means my number of hectometers, 115 kilometers, is equal to, and this is just that pattern that you guys are all super familiar with, 1,150 hectometers. So if you had 1,150 hectometers, you would have 115 kilometers. So, knowing about what I just did in this first part, to figure out decameters, which is, think about it, 100 times decameters gets me to kilometers. So if I multiply my amount of kilometers by 100, think 1 scoop, 2 scoops, 10 to the power of, think about how many groups that is. 100 is the same as 10 to the power of, everybody, 2. So, if I multiply that by 100, that means if I had 115 kilometers, I would have 11,500 decameters. I hope everyone is starting to be able to see the pattern. Please remember that this pattern changes when we're working with decimals, which often comes in with our smaller numbers. Then, if I'm going from kilometers to meters, and remember, you ask yourself, how many meters make up 1 kilometer? 1,000. So that means if I have kilometers and I want to know how many meters I have to multiply it by 1,000. Or, remember, that is 10 to the power of 3. 3 groups of 10. 10 times 10 times 10. So if I'm multiplying those together, that's going to give me my number of meters. So that would be 115,000. Hopefully that is making some sense. I think the more problems you do for the metric system, the easier it gets. I don't have many problems for your independent practice today because I just wanted to give you a little intro to it, and we'll come back to it. Over here, for centimeters to milliliters and milliliters to deciliters, you are doing the same thing. Right now we're going from centimeters to milliliters. So that means I'm going from a smaller unit to an even smaller unit. So that means there's going to be 10 times more milliliters than centimeters. They're one group different. So 40 centimeters would actually be like 400 milliliters. And then if I'm going from milliliters back to deciliters, it's getting